Last time we looked at how ions form. In this video we're going to have a little discussion about how these ions come together to form compounds such as everyday table salt. So let's begin. If we remember back to the periodic table for a moment, we'll remember that it's made up mostly of all these metals here that I've shaded in orange, and then all these non-metals here that I've shaded in purple. It is separated by this staircase that we look like in here, which are metalloids. Now, often different types of atoms, such as the two atoms that I've represented here, like to come together to form bonds. Now that is to say, they like to stick together, so to speak, as if there's some kind of glue that holds the two atoms together. Now, depending on what type of elements are involved with these two atoms coming and sticking together, depends on what type of bonding process that occurs. So here are a list of the three types of chemical bonds that can occur. But today we're going to focus on ionic bonding, which is a bond between a metal and a non-metal, which forms what we call an ionic compound. While there are many different types of ionic compounds, some of these can include sodium bromide, potassium iodide, or the most well-known one, calcium chloride, which is more commonly known as table salt. So let's use calcium chloride as an example to explain how ionic bonding occurs. Now, calcium chloride are made up of two different atoms. They're made up of sodium, which is a metal atom, and chlorine, which is a non-metal atom. Now, a lot of people can get themselves confused about the difference between chloride and chlorine. They are actually the same atom. However, in the process of forming this ionic compound, chlorine has become a negatively charged atom, which we refer to as an ion. When an atom becomes a negatively charged ion, we usually drop the last part of the name and replace it with IDE. So in this case, chlorine, we've dropped the "ene" for chloride. So if you see IDE in the name of an element, it simply means it's become the negative ion of that element. Now, to help explain how this process occurs, I've already drawn up the electronic configuration for both the sodium atom and the chlorine atom. Now, the first thing that you'll notice about these atoms is they've both got an incomplete outside shell. Now, while atoms prefer to be balanced, they more prefer to have a full outside shell. So sodium here has one of two options. It can try to gain another 7 electrons to fill this outside third shell, or it could just simply donate its most outside electron to another atom. Now, donating just this one atom is a lot simpler than trying to gain another 7 of them. Now, similarly, chlorine over here would like to have a complete outside shell. Now, in this case, it's easier for chlorine to gain 1 electron than try and give away 7 of its outside electrons. So, under the right circumstances, when sodium and chlorine atoms come together, sodium gives away an electron over to chlorine's outside ring, which I've then represented in the following diagram. Now that sodium has given away one of its electrons, it's got one more proton than electrons, so therefore it's formed a positive charge. The chlorine atom has gained another electron, so now the chlorine atom has one more electron than protons, so it's now got an overall negative charge, and we refer to it as chloride. Now, like many things in science, opposites like to attract. So if I've got a positively charged atom here, and I've got a negatively charged atom here, they come and stick together. And that's because they've got opposite charges. Now, because this bond has occurred between two different ions, we refer to this as an ionic bond. and it forms an ionic compound. Now, when it comes to naming an ionic compound, we always start with the cation or the metal of the two elements first, and then name it with the non-metal or the anion. So in this case, our metal or our cation is calcium, and our anion or non-metal is chloride. So let's revise. An ionic bond is between a metal over here and a non-metal. For one to occur, the metal has to give one or more of its electrons to the non-metal. This causes them to become ions with opposite charges. This opposite charge causes them to attract to each other and stick together. This sticking together we call a bond, more specifically an ionic bond.